Alright guys, so this is Mr. Farina to help you guys with your textbook, page 491 and 492. This is page 491 here. So what you're going to do, remember you guys can write in your textbooks, take a picture of it, and upload it to your teachers here in Google Classroom. Or you can, actually I think that's what we're trying to have you guys do this time. But I would save your work in case you do it and for some reason that isn't working. And again, contact us during these like office hours, those Zoom conferences. If you have questions or send an email, we'll be able to help you guys out too. Try to figure that out. So questions 19, 20, and 21, it wants you to distribute your things, your numbers here. So it says 4 times 38. So that's the same as 4 times 30 plus 4 times 8. So you're going to try that for 20 and 21. For 22 through 24, it wants you to use the distributive property to rewrite each algebraic expression. So this is what we did in Miss Gonzalez class. We talked about like the little eagle, right? First you do this one and then you do this one. And it looks like a little eagle here. If you put a little eye right there. I know it doesn't look very good. So let me actually just rewrite it here. So 4x plus 2. So I'm going to do 4 times x first, which is 4x, right? And then I'm going to do 4 times 2. So I bring down my plus sign, and I'll have 4 times 2, which is 8. So 4x plus 8. And notice that it looks like a little eagle, right? This looks like a little, if I do this, he's like here, and it's like, ka, ka. It doesn't look too much like an eagle right now. But once you do that, that's how you know you distributed both sides of it. So I have 4x plus 8. So you're going to try it here on the next question. Remember, you're going to distribute here, and then you're going to distribute here. So do that for 22 through 24. 25 says, be precise. Mrs. Singh bought 9 folders and 9 notebooks. The cost of each folder was $2.50. Each notebook cost $4. Write 2 equivalent expressions and then find the total cost. So what I'm going to do is I'm going to say 9 times, right? And the cost of each folder was $2.50. Whoa. Plus the cost of each notebook is $4. So once you distribute that, you'll be able to figure out your total cost. Or I think it actually wants you to do the 2 equivalent expressions, so then you could have done 9 times 250 and then 9 times 4 and you got your answer that way as well, once you add them together. So let me see here. Number 26. Be precise. 5 friends bought admission tickets to the museum and a box lunch. The cost of each admission ticket was $11.75 and each box lunch was $5. So write 2 equivalent expressions and then find the total cost. So you can do the same thing here, guys, as we did on number 25. On number 27, it says 27 plus 12. Factor each expression. So what we're looking for on this one is GCF. So if you guys remember GCF, that's our greatest common factor. So what number goes into both 27 and 12 that we can factor out? That's what we're trying to do here. So let's say, can I divide them both by 2? I can't. Can I divide them both by 3? I can, right? Because 27 divided by 3 gives me 9. So let's do that. I'm going to take out 3 from each of these. So if I divide them both by 3, and this is where you can actually set it up a couple different ways. I know one way we learned is to do this method where we do an upside down cake. So I'm dividing by 3. I get 27 divided by 3 equals 9. I know it looks like a weird 9. And then 12 divided by 3 equals 4. And now I think, can I go any further? Is there any numbers that go into 9 and 4 evenly? 2 doesn't go into 9 or 4. 3 doesn't go into 4. 4 goes into 4, and that's it. So no, I'm done here. So this is my greatest common factor. So when I factor it out, all it is I'm doing 3 and then 9 plus 4. That's how I factor this out. So let me try another method that we could have done. Let me erase my stuff real quick. I could have also just done because I know some of you guys do the towers. So you're going to do this, write your greatest common factors for this, and then pull them out. So I have 1 and 27 whoa, can't write very small. 3 times 9. Then nothing else goes in there, right? 4 times nothing, 5 doesn't go in 27, 6, 7, 8, 9. So that's it. My factors are 1, 27, and 3 and 9. So now I'm going to do it for 12. So I have 1 times 12, 2 times 6, 3 times 4, 5 doesn't go into 12, and then 4 times 3 again, right? So now I'm just going to look for my biggest number in both of these little factor trees here. So I have my my 3 here, and my 3 here, and basically just 1, right? So my biggest one is 3. So that means I'm just going to take 3 out, and like I did before, 27 divided by 3 equals 9, and then 12 divided by 3 equals 4. So that's the same answer, 3, 9 plus 4. So that's another way of doing it. So you're going to try that for all of these right here. Let me just work out one more. I'll do number 31, let's say. So I'm going to do the same thing. And let me see if I can zoom in and make this a little easier for myself. One sec, guys. Nice, it looks like I can. So what I'm going to do is I'm rewriting this question, right? I have 30 plus 12x. And now I'm going to, let me see here, factor out what numbers can I do this. So again, I like doing that method where we do the factor tree. So the upside down cake. So I'm going to start like this. And what numbers can go into both of these numbers? Well, let's just start easy. 2. They're both even numbers. So 30 divided by 2 equals 15. And 12 divided by 2 equals 6. Now, could I keep going? Let's try my next layer. Is there any number that goes into both these numbers? 2 can go into 6, but it doesn't go into 15. 3 can go into 6, and 3 goes into 15. So I'm going to divide by 3 now. So 15 divided by 3 is 5, right? 3 times 5 equals 15. And 6 divided by 3 equals 2. And then that's actually where it's going to stop, because I have a prime number here, 2. So the only numbers that go into 2 are 1 and 2. And I know that I'm basically stopped there, right? 2 doesn't go into 5. So then I'm going to take these two numbers on the side and multiply them together. 2 times 3 equals 6. So that's what I'm going to factor out of this equation. And it's actually cool, because if you do it this way, you're left with what you're going to have inside the parentheses. So 6, and I had, this was x and x, right? So I need to keep my x there as well. So I have 6, and in the parentheses I'm going to have 5. And what do I have here? I have a plus sign, so I'm going to say plus, and then my 2x. So that's how I distributed it out. And that is number 31. I know it's a little tricky, and we did do it in class a few times. It's just, it's been a while, so it's going to be a little bit tricky for some of you guys. Try your best and ask if you are still confused, all right? And this is another way actually to check your answer to see if you got it right. What you can do is do the distribute method, right? Because we're doing the opposite of what we did over here. So 6 times 5 is 30. And then 6 times 2x should be 6 times 2 is 12. So I said 12 and bring my x along with it. And then my plus sign just goes right where it was at. So 30 plus 12x, is that what I started with? It is. So that's how I know I distributed it correctly. And again, here's my eagle, now that I learned how to zoom in on this thing. So that is page 491. Let's see about 492, one sec. Alright, so now we're on page 492. And it's asking, determine if each statement illustrates, where's my laser pointer? Here it is. Illustrates the distributive property, so like yes or no. So the distributive property again is when we distribute this across, and it should equal this number, right? So let's do that, and I'm going to zoom in real quick. Okay. So if I went here to here, 7x, right? 7 times x equals 7x. So that looks good so far. And then 7 times 1 should be 7, so 7x plus 7. Whoa, that's not what this equals, so then my answer for this one is no. And you're going to, again, see how that works for the rest of them and determine whether it's yes or no. Let's look at number 34. Toby and 3 of his friends ate lunch together at a deli. Each person ordered a sandwich and a drink. And our little keys over here. Toby and 3 of his friends ate lunch together at a deli. So if it's Toby and 3 of his friends, how many people is that? That's what we need to figure out here. That's where a lot of people, I think, were confused, or can be confused. So Toby and 3 of his friends. So how many people? It says fill in each box to write an expression to represent the amount they spent together. So how many of them are there? Or there you go. How much did Toby and his friends spend together? That's our answer. But how many of them are there? There is 4 of them, right? They each order the same thing, which is $2.75 for a sandwich and $1.25 for a drink. So we're going to say $2.75 right here and $1.25 for a drink. So now when you distribute this across, you will have your answer, right? All right, and that is how you do this one. You can either distribute it across, or actually I'll let you guys play with that one and see if you can figure out a different way to do it. But yeah, it wants you to distribute. That's what we've been practicing. Now this is Common Core Spiral View, which means we're doing stuff from the past. This is actually stuff you learned in 5th grade. That's what that 5 stands for. And let's see here. It says evaluate. We have 4 plus 5.25 and 23 hundredths plus 3. So we're just going to add all these together, right? That's all you're going to have to do. That's basically it on this one. I'm not really going to help you guys too much on that one because I would just say line up your decimals when you're adding decimals. Over here, looks like you're multiplying decimals, and you're going to go in order. Remember PEMDAS. I think I talked about it in a recent video as well. So PEMDAS, parentheses, exponents, multiplication or division, whichever comes first, and then adding, subtraction, whichever comes first. So on this one, that's going to be a factor on number 36. All right, 38. Elise and her sister Marta recorded the amount they saved each week for a month. How much did each person save? Use the information in the table to compare the total amount that Elise saved to the total amount Marta saved. So, again, I just want you guys to try that one out. This is Elise savings per week, right? And it wants to know how much she saved for a month. Each week for a month, how much did each person save? Use the information in the table below. Yeah, so you're just going to add them together and then figure out who saved the most, right? All right, number 39. Each bottle holds 16 fluid ounces of water. Bottles were packaged in 4 rows of 6 bottles. So how many ounces of waters are in each package? Those are our questions here. So on this one, it's a little wordy, but I mean, if there's 4 rows of 6 bottles, how many bottles are there in a pack? So it's like a pack comes, and there is 4 rows of 6. How many bottles would that be? And then we know there's 16 ounces, so that means you're going to multiply those numbers together, right, to figure out how many ounces of water are in each package. So 4 rows times 6 equals 24. That means it's a 24 pack of water, right? And if there's 16 ounces in each bottle, so 24 times 16, you'd have your answer. All right, guys, that's my help for homework 491 and 492. Come with questions if you have them. Good luck. And that's all I got for today. Have a good one. Be safe.